The book talks about two different things. There's what's called total surface area. And the book also throws at you something that is called lateral surface area. Okay. And the difference between those is this. If you remember back, surface area we said is just simply adding the area of all sides together. Okay, that is total surface area. All the sides added together. The difference between total surface and lateral surface area is lateral surface area is just the area of all sides added together. So that doesn't make sense, does it? Excluding the two bases. Yeah. Okay. You don't include, it's not, you can't really go by top and bottom because that refers to position. We talked about the whole loaf of bread theory there. We kind of give you a little gist here. This, you got that written down?
No.
In other words, if you had a shape that looked like this, okay, if you had a shape that looked like this, total surface area would be everything. Top, the bottom, the bases, the left side, right side, whatever. Surface, the lateral surface area would just be everything but that T shape. It would be this, plus this, plus this, plus this, plus this, plus the sides you can't see. There's a side over here that you can't see. There's this side here that you can't see. This side here you can't see. There's this little sliver of a side over here you can't see. So lateral surface area is just the area of the sides. You actually have to find lateral surface area to find total surface area. I mean, you're going to do this when you do that, so it's 6 to 1, half dozen to the other. And I'm not sure why they throw that at you, but we're going to draw a picture here, which is a goofy sort of thing. Draw this one here, and then we'll talk about it. A little L-shaped figure. You get a decent drawing here. Can you draw that? Let's see, 12, 12, 13, and, well, 12, 12, 15, and 20. 12, 12, 15, 20, and 10. Is it less than 10? 10? Is it 10? Okay, now, let's just throw this at you here. Okay. You can spend your whole life doing, we're going to do lateral surface area. Okay. You can spend your whole life multiplying and finding all the area of the sides. We are not, when we do lateral surface area, we're not including the area of this top L shape, and we're not including the area of the same L shape that's on the bottom. You are just including the area of this side, this side, this side, this side, and over here there's a side you can't see, and over here there's this side over here you can't see. Okay, that is what you're doing when you're finding the lateral surface area. It's the sides that, it's like if this was a building and then you were asked to paint the walls of the building, okay, you wouldn't paint the ceiling, it's a drop ceiling, and you wouldn't paint the floor, it's already tiled. You would paint all of these and that would be it. So to do that, you know, you're gonna, here's what you do. Let's do this. How many pieces do we have? We got shape number 1, shape number 2, shape number 3, shape number 4, let's do shape number 5 back here, shape number 6. Okay, let's do number 1. What would I multiply together to get number 1? I would do 12 times, how high is this?
10.
No, it's 10. Every line going up is 10. And that's 120, right? Shape number 2 would be 12 times, how high is it? 10, which is 120. Shape number 3 is 15 times 10. Thanks, Holly, for being there for me. Shape number 4 is 20 times 10, which equals 200. Shape number 5, what is the length from here to here, or this whole length from here to here? 12 plus, these two lines put together are going to be that same length, so that is what? Right, it is 32 times how high? 10, still 10. And shape number 6 is going to be these two lines put together, 12 and 15, 27 times 10, 270. And you're going to add all of these together to give you 0, what is this, 9, 14, 15, 16, 17, 18, 2, 4, 7, 8, 9, 10, 1180, let's say these are inches squared. That is lateral surface area. Everybody got that?
No.
Yeah.
What, Kendall, don't you get?
I don't get how, I know those shapes where you put like the numbers, but how did you get all the other numbers that you didn't put down?
How do I know that this from here to here is 27 or 32? Because it's what this line comes when you add this line plus this line together. This line is 12, this line is 20. 12 plus 20 is the same as that line. It's all apart, same thing. This long line here is the same as putting this line with this line together, and that's 12 plus 15, that's 27.
So for the where you multiply them, you don't like you put the ones next to each other?
I have no idea what you're asking. What ones next to each other?
Like 12 times 10, you put the ones next to each other.
Well, 10 is the height. The height of every one of these is 10. The height is going to stay the same. Everything is going to get multiplied by 10, which is hopefully where Alex is going to go at this next statement. Alex. Yep.
If you were to do a squared,
Wouldn't matter. Everything's a base. Everything's a base. Now, children. Kyle, do you need that chair? Children, listen carefully. To save yourself some time, Colton, shoot. To save yourself some time, there's a formula for lateral surface area. Maybe you'll be able to see this here. Lateral surface area can be more quickly done by, notice what we did here? Every one of these things we multiplied by 10, okay? By the height, every one of them. So instead of doing each one individually, you can combine the whole process into one by doing the perimeter of the base times the height. Okay? I could have done this more quickly if I would have just added, I could take 12 plus 12 plus 15 plus 20 plus what we figured this to be 27 plus 32, added those together, and then at the end multiplied by 10 rather than doing each one separately. You know, you're gonna. This one wasn't so bad. This one wasn't so bad because it was just by 10 every time. But could you imagine how long it would take this if this was maybe 14 or something where you had to double-digit multiply the whole thing? So I could have done 12 plus 12 plus 15 plus 20 plus 32 plus 27, 9, 10, 11, 12, 13, 8, 118, and then multiplied that by 10 and got 1,180 before that. This is something important to remember because it will save you some time on some shapes. Other ones, it's not that much of a time saver, but on something that gets a little more complex like this, it would save you that. Now, if I asked you for the total surface area, okay, you've already done most of the work. You've already found all the area of all the sides. We already have the 1180. You just need to find the area of the base. You just need to find the area of this, sorry. You just need to find the area of this, and there's two of them. There's a top and a bottom. So what is the area of that? Well, let's do it here. If you cut it into shapes, you know the area of this rectangle is 27 times 20, which is, thank you, 540. And then that would be, in addition to that, you'd have to add this to it, which is 12 times 12, 144. So the area of the top is 144 plus 540, which is 684. Yes, just agree with me.
Yes.
Am I done now? No, I still have to, right, do the bottom, which is the same though. You add those three things together, and that is the total surface area. Okay, lateral surface area, just the sides. Total surface area is the side plus the two bases. Whew. Josh?
For the top one, which is 27, didn't you add 12 and 15?
I did. Is there a question in your statement? Yes. This 27 came from when I added 15 plus 12. That's that long line. This 32 came from when I added 12 and 20. Kendall?
Where did you get 684?
Well, the area, let me do it in black. Kendall, the area of this rectangle right here, which was 27 times 20, 540, I had to add to the area of this actual square, which is 12 times 12, 144. The area of the whole top is those two combined, which was 684. And I have two of those because there's this top and the bottom that I can't see. They're the same shape. And that completes all the sides there are to this shape. A top and the bottom, and the 1, 2, 3, 4, 5, 6 sides that it has.
Wait, is that for the total surface?
That is for the total surface area.
Ah,
The lateral surface area was just the 6 sides. The total surface area I had to add the 6 sides plus the top and the bottom. Whew. Alex Vollmer.
Is it possible to do this with triangular prism?
Absolutely. It'd be the same thing.
Any shape?
Any prism. Now you gotta be careful with pyramids because pyramids come to points, so there's not two bases on a pyramid. A pyramid only has one base shape. Then you got slant heights to it, and that throws things off just a little bit. If they do, in fact, if they give you just a rectangular prism, okay, we talked about this a little before. With my loaf of bread theory, with the loaf of bread theory, obviously anything could be the base. But if they give you this and tell you to find the lateral surface area, okay, you're assuming that the thing that the top and the bottom are the two bases. That the sides would be the sides that you can see that are the sides. If they give you a rectangular prism. Because they might ask you to find the lateral surface area. Like the lateral surface area of this room. You have to assume that the walls are the sides, not the top, even though in reality, anything could be the base, because it doesn't matter. Kendall!
the for our homework, do we have to write down like 1, 2, 3, 4, 5, 6, 7?
You can use the formula if you like, but you certainly want to sketch the problem. What's that?